I am Dr. Rishi Paliwal on behalf of Dr. Shivani Rai Paliwal with another interesting and learning episode of B.Pharm on the important unit of metal containers, which is very important unit of the section of pharmaceutical packaging technology. B.Pharm 7th semester. Let's start our episode while taking a look at what we are going to learn today. Module 1 Introduction, Metal Container, Module 2 Aluminium and Tin Plate, Module 3 Drums, Module 4 Collapsible Tubes and Aerosol Containers, Module 5 Lacquering, Coating and Lining, Module 6 Conclusions. Module 1 Introduction, Metal Containers. Let's start with general introduction about various metal containers for pharmaceutical products. The container is the device that holds the drug. The immediate container is that which is in direct contact with the drug at all times. Metal containers are used solely for medicinal products for non-parenteral administration. Metals are used as containers as early as 4000 BC and probably before that. But the use of metal in packaging appears to be on a slow decline in present scenario because the trend towards continuing reduction in weight has meant that more containers are being made from the same overall weight of metal. It is therefore remains generally competitive with other materials, particularly as it can be manufactured and filled at high speeds. However, metal is being increasingly challenged by plastics, glass, and composite materials which involve a wide range of coating processes such as metallization, silica oxide, and carbon. Advantages: metal containers are strong, relatively unbreakable, opaque, and impervious to moisture, vapor, gases, odors, and bacteria, providing they are pinhole free, resistant high and low temperature, available in a variety of shapes, size, and styles, ranging from small elongated collapsible tube and shallow drawn containers to large built-up containers. Metal containers exist in many different styles. Most are parallel-sided and of relatively simple cross-section, that is square, rectangular, oval, or circular. The majority being circular. This is due to limitation in manufacturing techniques which do not apply to glass or plastics. However, the technique of building up metal containers from sheet by means of seaming confers one advantage over glass and plastic in that right angles can be easily achieved. Ideal packaging material for pressurized containers. Disadvantages or limitation with metal container. Number 1. Metal require the application of coating and lacquers to prevent chemical reaction and corrosion from the inside or outside, like tin plate is in fact a coated material discussed in upcoming lecture. Number 2. Expensive. High weight in comparison to plastics. Types of metal containers. Metal containers can be classified into several general categories based on methods of manufacture as follows. Number 1. One-piece seamless containers. Formed foil or sheet. A formed aluminum foil container is made by forcing the material to assume a shape with little or no metal draw. Shallow drawn. The process whereby an article is formed by drawing or pressing it form a sheet of the material using matching male and female dyes. Drawn and redrawn and wall ironed. Deeper containers or more complex shapes can be produced either by drawing or redrawing or by a combined drawing and wall ironing process. Impact extruded. The impact extrusion process is used to produce open-ended collapsible tube from softer material such as tin and lead. Number 2. Multiple piece built up or fabricated containers. Open top, closed top, aerosols. Dear students, till now we have seen that there are different types metal of container based on methods of manufacturing. Now we will discuss metal based containers. First, we will try to know about aluminum and tin plate. Module 2. Aluminum and tin plate. Tin plate. Tin plate is mild or low carbon steel sheet or strip which is coated on both sides with commercially pure tin. With pharmaceuticals, metals, particularly tin plate, was at one time widely used for pastille tins, ointment tins, and various built up containers for powders, tablets, capsules, etc. Advantages. This metal is very resistant to chemical attack. Readily coats a number of the metals, that is tin coated lead tubes combine the softness of lead with the inertness of tin, and for this reason it was formerly used for packaging fluoride toothpaste. Disadvantages. Tin is the most expensive metal among tin, lead, aluminum and iron. Uses. Number 1. Tin containers are preferred for foods like milk powder containers are coated with tin. Number 2. Currently, some eye ointment still packaged in pure tin ointment tube. Manufacturing of tin plate. The technique of building up metal containers from sheet by means of seaming confers one advantage over glass and plastic in that right angles can be easily achieved. Blown glass or plastic containers require ready, particularly at the base of the container, in order to avoid excessive thinning. The use of sheet material also allows decorating before container fabrication instead of after, with fewer limitations than for processes applicable to finished containers. In figure 1, you can see the process of tin plate manufacturing. In the upper part, you can see then we take tin plate blank, then we go for wire welding, and then we make the can body. Two-piece cans can be taken after soldering, and the two ends can be added at the last. In the lower part you can see we can choose tin plate disc. Using the process of cupping and drawing, we make the punching and redrawing as well as ironing. Then there is no side seam in this case, and we add the two tops for making the tin plate. Aluminium. Aluminium sheet is used for drawn or formed one-piece container bodies and also in the fabrication of multi-piece built-up containers. Advantages. Number 1. Aluminium is a light metal, hence the shipment cost of the product is less. Number 2. Aluminium is very malleable and ductile and easily formed into containers. Number 3. They provide attractiveness of tin at somewhat lower cost. Number 4. The surface of aluminium reacts with atmospheric oxygen to form a thin, tough, coherent, transparent coating of oxide of atomic thickness which protects the metal from further oxidation. Disadvantages. Number 1. Any substance that reacts with the oxide coating can cause corrosion. That is, products with the oxide coating can cause corrosion. That is, product of high or low pH, some complexing agent, etc. Number 2. As a result of corrosion process, H2 hydrogen may evolve. Use. Aluminium ointment tubes, screw caps, aluminium foil, usually as laminations for blister, strip and sachet packaging. Sometimes internally lacquered aluminium containers are used to stop the reaction with the content. Module 3. Drums. Drums are defined as single-walled shipping container of capacity 13 to 110 US gallons, whereas containers of less than 13 gallons are called pails. In the UK, pails may be referred to as kegs. Pails are constructed from steels of 29 gauge to around 24 gauge. Lightweight drums up to 55 gallons are constructed in steel ranging from 26 to 20 gauge. Heavy drums vary from 18 to 14 gauges. If the ends of drums are constructed of a different gauge from the sidewall, the gauge of the sidewall is coated first and then the ends. That is, a 20 by 18 drum has 20 gauge sidewall and 18 gauge ends. Specification for pails and drums for packaging dangerous or hazardous products such as acids, flammables, explosives, and poisons are regulated by the US Department of Transportation Regulation. Types. Number 1. Open-headed or full aperture. Used for dry products, semi-solids, and viscous liquids. Closures for open-headed pails and drums are full diameter lids. The seal is usually effected by a rubber or plastic gasket contained in a channel in the lid. Number 2. Tight-headed are used mainly for liquid. They implies that the top of the container is permanently secured by the drum manufacturer. Aperture for filling and emptying being provided in the lid itself. The most commonly used closure is probably the trisure. This consists of an externally threaded bung fitted with a plastic or rubber gasket plus an overcap. Pails are small enough to be handled manually. Steel handles are often attached for this purpose. It is also common to reduce the diameter of the bottom or top chime to facilitate stacking. These containers are widely used in the pharmaceutical industry for the in-house handling of tablets. Tight-headed pails with one closure only are often fitted with specially shaped tops which have a raised portion instead of a recess above the double seam. It is a special term generally used for outpatients. As they come, take care, and walk away, so the term ambulatory was used. The inner surface of drums and pails are usually treated, epoxy and polyurethane resins being the most common. Instead of applying the lacquer to the base sheet, it can be sprayed inside the drum. After fabrication, to ensure that all seams are adequately protected. This is particularly important for belted drums where the welding process destroys the original coating of the sheet. The container is then stoked to cure the resin. The efficacy of the coating depends to a large extent on correct surface preparation, that is mechanical roughening or phosphating. A phosphate coating is frequently used externally prior to decoration. Galvanizing is used for heavy duty multi-trip drums. In this instance, the complete drum is immersed in a bath of molten zinc. Hope these students would have been well understood the aluminum and tin plate for container with drums. Now we will move towards collapsible tubes and aerosol containers. Module 4. Collapsible tubes and aerosol containers. Collapsible tubes can be produced from any of the softer metal such as aluminium, tin, lead, and tin/lead alloys. Collapsible metal tubes are used extensively for packaging a wide range of pharmaceutical and cosmetic creams, paste, ointments, jellies, and semi liquids. Properties: metal tubes are impermeable to moisture, gas, odor, and light, provided they are adequately closed. Convenient for a customer or patient to use and as the content are expelled out by squeezing the tube. Not recover their original shape when the pressure is released. Consequently, the risk of air entering the pack and reacting with the product or cause it to dry out is minimized. Internal coating may be necessary to prevent chemical reaction. The joint properties of impermeability and collapsibility are advantages over most plastic tubes, which are not only permeable but also tend to snap back into their original shape after each application. Methods of manufacturing: A. The basic extrusion process used for metal collapsible tubes, except that the slugs used are rings rather than disc, and the female die which holds the slug is shaped so that the metal is forced downwards into the die to form the soldier and nozzle as well as upward around the plunger. B. The formed tubes then passes to a trimming machine where they are cut to length, a thread cut or rolled down the nozzle, and the face of the nozzle orifice is cleaned. The soldier, which is relatively rigid, may be decorated, that is, with concentric rings if required. The tubes are then ready for the finishing operation of internal coating, enameling, printing, and capping. Aerosol containers hold the content under pressurized condition and will provide a constant content release while the container is being emptied due to pressure produced by liquefied gas, also called as propellant. Another requirement which is likely to become of increasing importance with aerosols is the demand for child resistant and tamper evident closures. Manufacturing: aerosol containers may be produced by any of the main methods for manufacturing metal containers, that is, by impact extrusion in aluminum, by building up from tin plate, or by drawing and wall ironing. Those constructed in other materials is similar irrespective of the method of construction. The built up tin plate container is the cheapest form of aerosol but was initially considered unacceptable for most pharmaceutical products due to the unsightly appearance of the soldered side seam. However, the development of reduced width side seams by jet soldering, cementing, or welding, that is, soldering weld, makes the built up container a more attractive proposition. Aluminum aerosols are inherently more expensive than tin plate but can be made in one piece with neither side seam nor bottom chimney. However, for practical or economic reasons, these monobuoy containers are usually restricted to the smaller size of aerosols. Larger size are produced in two pieces, that is, with a continuous side wall and a seamed on base. In the past few years, the process of drawing and wall ironing has enabled continuous side wall containers to be produced from both aluminum and tin plate sheet. Unlike two-piece extruded body containers, these containers have no base chimney but instead have a seamed on cone. Propellant: the intimate mixture of propellant, gas, and product in a true aerosol provide a rapid expansion of the propellant as it leaves the valve orifice. Examples: fluorinated chlorinated hydrocarbons, paraffin hydrocarbons such as propane and butane, and inert gases. But the main disadvantage with hydrocarbon propellant is their flammability and the need for special filling plant. Valve assembly. The valve is designed to dispense the product in the required manner while maintaining both the product and propellant hermetically sealed until the product is expanded. This breaks up the product into small particles, giving a fine mist, coarse spray, foam, or dust according to the nature and relative quantity of the product and the propellant and the type of valve like spray, foam, stream, metering, and drops dispensing valves. Valve cup. This is mounted the valve housing into which fits the valve stem itself, usually formed in tin plate and incorporates a grommet or flowed in compound lining, usually nitrile rubber, to ensure a leak proof seal with the cone. The method of losing the valve cup into the cone, known as crimping, clinching, or more correctly, swagging, consists of mechanically expanding the valve cup just below the curl of the cone so that the joint is mechanically filling and packaging. The process of filling aerosol containers involves four main operations, namely product filling, purging, swagging, and propellant filling, the order of which may be varied. There are two filling methods, cold filling and pressure filling. In cold filling, both the product and propellant are refrigerated and filled volumetrically as liquid through the 1-inch aperture before the valve is swagged into position. This process is self-purging. Pressure filling also begins with the product filling, but the propellant is handled as a gas. After the product has been filled, allowing for head space, it is purged with propellant vapor and the valve swagged or cleansed in position. The bulk of propellant is then filled either through or around the valve system. Pressure filling equipment is more expensive than cold filling equipment, but the running costs are lower. With all these processes, removal of the head space air by vacuum or purging with propellant vapor is essential, as otherwise the internal pressure would be lowered. After filling and closing, the containers are tested in a water bath at 55 degrees Celsius or above to check for leakage. The containers are then dried and the buttons applied. All containers are spray tested in a special spray booth. Unprinted containers are then labeled and covers applied. At this stage, some products are trade off, then checked, weighed for losses following a storage period, allowing for swelling gasket. Cautions. Cautionary wording such as pressurized container, protect from sunlight, do not expose to temperature exceeding 50 degrees Celsius, do not puncture or burn even after use, do not spray on a naked flame or any incandescent material is mandatory in many countries. Module 5. Lacquering. Lacquer is a clear or colorant wood finish that dries by solvent evaporation or a curing process that produces a hard, durable finish. This finish can be of any scene level from ultra matte to high gloss, and it can be further polished as required. It is also used for lacquer paint, which is a paint that typically dries better on a hard and smooth surface. The application of lacquer on a surface called lacquering. Most internal lacquering systems involve two coating, the first being partially dried before applying a second coat and drying completely. Needless to say, where lacquers are used, it is essential that they be pinhole free for the whole length of the inside of the tube, including the interior of the nozzle. After the internal coating has been applied, the tubes are enameled externally. Types of lacquer. Number 1. Epoxy resin based, that is epicoat or araldite resins cured by amines, phenols, etc. Number 2. Epoxy esters. Esters produced by reacting epoxy resins with drying and non-drying oil fatty acids. Number 3. Vinyls polymers or copolymers based on vinyl chloride, that is vinyl chloride, vinyl acetate, vinyl chloride, vinyl acetate, vinyl alcohol, vinylidene chloride, vinyl chloride, etc. Lacquers based on 1 and 2 are generally referred to as high stoving lacquers and the others as low stoving. All of these have excellent chemical resistance, mechanical flexibility, and adhesion, providing the inherent chemical resistance of one of these types is sufficiently high in relation to the product with which it is envisaged to be used, and its other properties satisfy the conditions required for container work. The lacquer itself becomes the least important factor governing the success or failure of a protective system. It is rare when examining a lacquer failures to find that the lacquer itself is at fault, and it is equally rare to find a lacquer that has failed because it has been chemically attacked. Properties. The first point to be realized is that all protective lacquers films are permeable and transmit oxygen and water. Nevertheless, they do provide protection if applied in the correct film thickness for a particular product. Lacquer damage. One or two imperfections in the film can be highly dangerous. If the surrounding film is such that it is appreciably conductive, a thickener film have a larger number of pinholes may perform satisfactorily, for under this condition corrosion at the site of imperfections may rapidly choke itself, whilst the thick film does not become cathodic. Other type of damage. Number 1. Excessive extrusion marks. Processing lines are inevitable but are to a large extent dependent on the condition of the tools used in extrusion and should be shallow and smooth. Deep tone marks cut through the lacquer film when enameling and printing pressure is applied, and it is quite usual to see a lacquered tube or container which has corroded along the whole length of a deep extrusion line. Number 2. Cross scoring. These are a very potent source of trouble where these transverse scratches intersect extrusion lines. Little sore spots of broken metal are formed which act as nuclei of corrosion on unlacquered metal and which give big areas of unsupported film in the case of lacquered containers. Null marks. These apply mainly to tubes but can also occur with narrow necked rigid containers and are caused by the use of steel null point or printing fingers which grip the container internally in the nozzle or container neck, leaving deep cuts or torn metal. It is possible to obviate these by using alternative devices. Properties. The lacquer itself must be suitable chemically. The lubricant used for impact extrusion should be purely organic. Metal soap such as zinc stearate should be avoided and if water soluble compounds, that is ethoxylated lanolines, can be used. So much the better, as subsequent degassing is going to be more effective. There must be minimum delay between extruding and annealing or degreasing. With rigid containers, solvent degreasing should be avoided. Aqueous treatment, giving a chemically clean surface and slight etch, should be used, and there should be no delay between final rinse and drying. The containers themselves should be free from deep extrusion lines and tone metal. Cross scoring should be absent. Null marks should be absent from the nozzles of collapsible tube. The containers should be processed on plastic covered spindles for operations subsequent to lacquering. There should be minimum delay between annealing or degreasing and internal lacquering. The nozzle diameter of a collapsible tube should be as large as possible to permit effective lacquering, or alternatively a plastic nozzle may be used. Testing. Effective way of determining the suitability or otherwise of lacquered aluminum containers is by subjecting a sufficient number of filled specimens to self-life test at varying temperatures, and by extracting specimens at regular periods and examining the product and product aqueous contact area visually and by means of a surface microscope. Lacquer coating and linings. Lining provides the product to be filled protection against the exposed surface of metal. The interior is coated or lined with wax, resins, or epoxy is sprayed on it. An epoxy sprayed container costs 25% more. Wax linings are used in water-based product. If the product is not compatible with bare metal, the interior can be flushed with waxy type formulations or with resin solutions. Although the resin or lacquers are usually sprayed on, a tube with an epoxy lining costs about 25% more than the same tube uncoated. Wax linings are most often used with water-based product and tin tubes and phenolics. Epoxides and vinyls are used with aluminum tubes, giving better production than wax but at a higher cost. When acidic products are packed, phenolics are used, and for alkaline product, epoxides are used. Module 6, Conclusion. With all these information, here we come to end of today's lecture. Hope we have understood the basic applications of metal container in pharmaceutical packaging. Further, have a look again on the complete topic yourself so that you are thorough with it. The topic that we have discussed today is very simple. So dear student, this is Dr. Rishi Paliwal taking leave from you with the hope that you enjoyed and understood today's lecture. If you want to learn more and enhance your knowledge, you may log on to our website for multiple choice questions, quizzes, LORs at www.cec.nic.in. Till then, keep studying. Goodbye.